All right, guys, we are starting on our next day here of online learning. Today we are going to work on something called 8.7, the law of sines. Okay, 8.7, the law of sines. Now, the law of sines is nice because what it allows us to do is it allows us to work with non-right triangles. Okay, allows us to work with non-right triangles. And what I mean by that is in the past, anytime that we wanted to use sine, cosine, or tangent, or any of the reciprocals, anytime we want to use those ratios, we've always had to do it with a right triangle. Well, what the law of sines allows us to do is work with the sides and angles of a triangle, even if it's a non-right triangle. Okay, so let's go ahead and write down the law of sines first, and then we'll get into kind of how it works as we're working with it. So here's the law of sines. I'm going to draw a picture here to get us going. So let's assume that this is a non-right triangle. I'm going to call this angle A, call this angle B, call this side C, and then the sides, or sorry, angle, I'll call this angle C. So we got angle A, angle B, angle C. The sides that are opposite those angles, I'm going to call them the lowercase of that. So I'll call this side A, let's call this side little b, and I'll call this side little c. And here's what the law of sines tells us. It tells us that side A divided by the sine of angle A is equal to side B divided by the sine of angle B, which is equal to side C divided by the sine of angle C. Okay, so this is the law of sines. All right, I'm going to make a note here. The reciprocals of these are also true. Okay, the reciprocals of these are also true. And what I mean by that is you could flip any of these statements over and it would also work. Okay, so if I wanted to do sine of A on top, side A on the bottom, that would also work when trying to work with the law of sines. There are certain times where it's going to be easiest for us to do that. So what I'd like to do first with this is anytime you get a theorem or anything like that, or a law in math, you should be asking yourself why. Okay, and we're first gonna start with this because it's important for us to look at like proofs in math. We're not going to prove this entire thing, but we're at least going to figure out half of this. Okay, so we'll say at least half why. Okay, so I'm going to actually, to help us prove this, go back to this picture that I drew. And let's go ahead and fill in a little bit of information on this picture. So let's assume that again, this is a non-right triangle. I'm going to go ahead and draw what we call in geometry an altitude from angle C down here to side C. If you don't remember that word altitude, that's okay. An altitude means it's a line segment that's perpendicular to the opposite side. Okay, meaning it creates a right angle here and a right angle here. Okay, so by doing this, what I've actually done is I've created two right triangles, one right triangle on the left, and then another right triangle over here on the right. Okay, and I'm going to call this altitude h sub 1. Okay, and I'm going to start by doing some geometric statements here. So what I'd like to do is let's look at angle B. And I want to write a statement that describes the sine of angle B. Okay, so I'm going to say sine of B. And we know from just basic trig that the sine of an angle is the opposite side, which is h sub 1, divided by the hypotenuse, which for us would be side A. Okay, and I'm also going to come over here and do the same thing with angle A and write a statement for the sine of angle A. Okay. Well, what this would look like is sine of A is the opposite, which again is h sub 1, divided by the hypotenuse, which for us would be side B. Okay. Now, what I'm going to do next is I'm going to solve both of these statements for h sub 1. So in order to do it here, I need to multiply both sides by a. And in order to do it here, I need to multiply both sides by b. So that would cancel out these a's right here. I'd be left with a times the sine of b equals h sub 1. And then over here, this would cancel out these b's, and I would be left with b times the sine of a equals h sub 1. Okay, so what we've done here is we've created two separate statements that are both equal to h sub 1, which means I can also set the left side of both of those equations equal to each other. So I can now set up another statement that says a times the sine of b equals b times the sine of a. Okay, and now all we're going to do is some basic algebraic manipulation here to get this to look like the law of sines. So here's what I'm going to start with. I'm going to divide both sides by the sine of a. Okay, which gets me to this, a times the sine of b divided by the sine of a equals b. And then if I want to get rid of this sine of b right here, what I would need to do is multiply both sides by 1 over sine of b, because that cancels out the sine of b here. And then on this side, I'm just left with b over sine of b. Okay, so this is now gone, so I'm left with a divided by sine of a equals b divided by the sine of b. Okay, and what you'll see here is this is the first half of the law of sines. Okay, we saw this where I wrote it down here, first half of the law of sines. Now we haven't completely proven this. I'm going to stop here. It's not too hard to get the rest of the law. You just redo the same process, but using drawing an altitude from a different angle. But this is the first half of the proof. I'm not going to ask you to reprove this, but one of the reasons why I'm doing this is because I think it is important for us to understand where things come from in math. It's not just something that somebody wrote down and hoped that it worked. It does come from somewhere, and this is the start of why this law of sines actually works. But I'm not only concerned with the why, I'm more concerned with, can you actually apply this? So let's go ahead and let's jump straight into an example. You are going to need a calculator for this, but it's not too hard to work through these. So let's go ahead and jump right in, and here's the directions here. What we're going to do is we're going to solve for all missing sides and angles. Okay, solve for all missing sides and angles. I'm going to go ahead and draw a picture here. My pictures are not going to be super pretty, but I'll do my best. Okay, so let's go ahead and I'm going to give you this information. This angle is up here is 43 degrees. This angle here is 97 degrees. And this side over here is 25 units. Okay, that side right there is 25 units. Okay, so you can go ahead and label these angles however you want, sides and angles however you want, as long as they fit into the law of sines. I'm going to go ahead and call this angle A, call this angle B, and then I'm going to call this right here side C. Okay, which means that this would be, start filling in different color here. This would be angle C because it's opposite side C. This would be side B, and then this over here would be side A. Okay. All right, so let's jump into starting to solve this. Now I do know two of these angles already, and as long as I know two angles, I can always figure out the third, because all angles of a triangle add up to 180 degrees. Okay, we know that from basic geometry. So if I want to find this angle here, I'm going to do 180 minus 97 minus 43. And when I'm done, I know this angle right here has to be 40 degrees. Okay. All right, next up, now I can start solving for the missing sides of this triangle. Okay, I got all the angles, now I need the missing sides. Now, what I have right now is a complete pair in side C and angle C. Okay. Now you can solve for the other sides in whatever order you want. I usually like to go from the largest side to the smallest side. And what I know right here is the largest side has to be side B because it's opposite of angle B. Okay. So I'm going to go ahead and write out a statement here using the law of sine. Side B divided by the sine of angle B is equal to side C divided by the sine of angle C. Okay. And the only thing that I need to do to solve for B right here is multiply both sides by the sine of 97 degrees. Okay, that's going to cancel this out here. And it's going to give me an answer for side B when I'm finished. Okay. So if I come over here to my calculator, one thing I need to make sure of is that my calculator is in degree mode. It is currently in radian mode. So I'm going to change it into degree mode. Go back to my home screen here. Sorry, second quit. And let's do some math. So I'm going to go ahead and first of all do 25 divided by the sine of 40 degrees. That's going to give me my answer for this. And then I need to multiply that by the sine of 97 degrees. Okay, and when I'm done here, I get that side B is 38.6. We'll just round to one decimal place here, 38.6 units. Okay, so let's go ahead and mark that down. It's 38.6. Okay, and the only other thing I need to solve for is side A. Okay, now you can go through and you can use, now you have two complete pairs. You have angle C and side C and angle B and side B. You can go ahead and use whichever one you want here to solve for A. Because I already knew angle C and side C without doing any rounding, I'm going to go ahead and use that again. So let's do side A divided by the sine of angle A equals side C, 25, divided by the sine of angle C, which is 40 degrees. And once again, to solve for A, I just need to multiply both sides by the sine of 43 degrees. Okay, so I'm going to come over here to the calculator and let's do that. So I'm taking this side and then I need to multiply it by the sine of 43 degrees. Okay, when I'm finished here, I get that side A is 26.5 units. Okay, one thing you can do when you're finished with a problem like this is just make sure that everything matches up. The largest side is opposite the largest angle. The second largest side is opposite the second largest angle. And the smallest side is opposite the smallest angle. Everything's checking out, so we have solved this triangle completely. Okay. All right, let's try another one here. So same directions as before. Okay, let's take a look here. I'm gonna call this, we'll go A, B, C. Okay, and I'm gonna tell you that side A is 22 units. Side B is 12 units. And angle A is 42 degrees. Okay, and we're solving for all the missing sides and angles. Okay, and what I have right now is I have a complete pair in angle A and side A, and I only have side B. So the first thing that I have to solve for here is angle B. Okay, and just a little hint, whenever you're trying to solve for an angle, you're going to want to use the form of the law of sines that has the angle on top instead of the side. Okay, so right off the bat here, I'm going to start by setting this up as sine of angle B divided by side B equals the sine of angle A, which is 42 degrees, divided by side A, which is 22. Okay, and in order to solve this, the first thing I need to do is multiply both sides by 12. Okay, and let's do that on the calculator. So we get sine of 42 degrees divided by 22. And then we need to multiply that by 12. Okay, so when I'm done, here's what I've got. Sine of B equals, I'm going to round this, I'll round this to about 5 decimals, 3.64978. Now, we have not finished solving for this problem yet, and I'll put a ... at the end here to signify this actually keeps going. But what we found is we found the sine ratio for angle B, okay? So what we now need to do is we need to ask the calculator to figure out what angle has this sine value. Well, this comes back to inverse trig functions, which we've already been doing. So what we need to do is we need to ask ourselves which angle, arc sine, has a sine value of this ratio right here. And instead of typing all this back in again, what I'm going to do is second entry, sorry, I said that wrong. Second sine, not second entry, but second answer, okay, which asks the calculator to find the sine value or find the angle that has this sine value right here. Okay, press enter, and when I'm done, what I get is that angle B is 21.4 degrees. Okay, 21.4 degrees, right? Now from here, once we've got this, the rest of this should run pretty smoothly. I can now figure out angle C because I have two of the angles. So I'll do 180 minus 42 minus 21.4. Okay, and when I'm done, I get the angle C here. It's 116.6 degrees. Okay, makes sense. This is a really large angle. You can tell from the way that I've drawn this. So it makes sense that that would be our biggest angle here. And the only other thing that I don't know is I don't know side C right here. So I can now find side C. I'm going to go ahead and use the form of the law of sines that has the side on top since I'm trying to solve for a side. So I'll go side C divided by the sine of angle C, which I just found to be 116.6 degrees. And you can use whatever pair that you want, but I'm going to go ahead and use the pair with side A and angle A since I already knew those based on the given information. So that'll equal side A, which is 22, divided by the sine of angle A, which is 42 degrees. And let's solve this. So all I got to do here is multiply both sides by the sine of 116.6. So let's do 22 divided by the sine of 42. So that's this times the sine of 116.6. And when I'm done, I get that side C is 29.4 units. Okay, so I'll come over here, fill this in, and let's just check to make sure that everything matches up. Largest angle, largest side. Second largest angle, second largest side. Smallest angle, smallest side. Everything's looking good. So we have solved this right triangle. Okay. All right. A couple other little things here. Let's try this problem here. Instead of me drawing the triangle for you, I'm going to give you some information. So I'm going to tell you that side A is 15 units. Side B is 25 units. And angle A is 85 degrees. And what I'm going to say here is solve for sides and angles, and then draw. Okay, so we're going to solve for the sides and angles of this triangle, and then we're going to try to draw this triangle. Okay, what you'll notice here is we already have side A and angle A, so we have a complete pair. And we have side B, which means the first thing that we need to solve for is angle B. Okay, because we have side B, now we can solve for angle B. So if I'm trying to solve for an angle, I want to use the form of the law of sines that has the angle on top. So I'm going to go ahead and write this as sine of angle B divided by side B equals the sine of angle A divided by side A. Okay. And let's try and solve this. So I need to multiply both sides by 25. So I've got the sine of 85 divided by 15. Okay, and then I need to multiply this by 25. Okay, so when I'm done here, here's what I've got. Sine of angle B equals 1.66, and then it keeps going. Okay. Now, right off the bat, you should notice that there's something wrong with this. Okay. Right off the bat, you should notice that there's something wrong with this. Okay. If you recall, the ratio for sine is opposite over hypotenuse. Okay, you should be thinking to yourself, in a right triangle, the longest side always has to be the hypotenuse. So what's wrong with having a sine value that's larger than 1? Okay. Well, the only way that we're going to get a sine value that's larger than 1 means the numerator has to be larger than the denominator. Okay. For example, if I did 1.66 divided by 1, this would give me an answer of 1.66. But the issue here is, if this is the opposite side, and this is the hypotenuse, this is impossible. You cannot draw a triangle in which this is happening. Okay, this is impossible. So even if you go over here and ask the calculator to do this, in this case we need to do arc sine of this answer, what you'll see is the calculator says there's an error here, it can't do it, because the calculator cannot calculate an angle with a sine value because an angle with this sine value doesn't exist. Okay, so in fact, this triangle itself, this triangle does not exist because there's no way for me to draw it. Okay, that triangle does not exist. All right, so if you ever see this as kind of a special case, if you ever see this, you can say, well, that triangle doesn't exist because it's impossible for me to get that sine value, because it implies that I have a right triangle in which the opposite side is larger than the hypotenuse. That cannot happen. Okay? All right. One more thing for this video. I'd like us to real quickly try, let's try a word problem. Okay? So here's our word problem. Tom and Jerry are 100 feet apart from each other. Okay. Angle of elevation from Tom to a balloon in the sky is, we'll go 39 degrees. Angle of elevation from Jerry to the same balloon is 65 degrees. How far is Tom from the balloon diagonally? Okay. Now, as is the case with most word problems, the best way to start this is by drawing a picture. Okay. So let's draw a picture. Here's Tom, here's Jerry, here's a balloon. Okay. It says angle of elevation from Tom to the balloon is 39 degrees. The angle of elevation from Jerry to the balloon is 65 degrees. It wants to know how far is Tom from the balloon diagonally, and we already know that they are 100 feet from each other. Okay. Well, once you draw a picture, you can see this is actually the exact same type of problem that we've been working on. All right. In order to do this, we first need a complete side and angle. Well, we don't have that yet, but we know we can get this other angle by, let's see, let's clear all our work here. We know all these angles have to add up to 180 degrees. So 180 minus 65 minus 39 tells us that this angle right here has to be, switch colors, 76 degrees. And now we have a complete side and angle, okay? But we need to figure out this other side right here. Okay, so question mark divided by the sine of its angle equals the complete side and angle that we have would be 100 feet divided by the sine of its angle, which is 76 degrees. And the only thing that I would need to do to figure out question mark is multiply both sides by the sine of 65. So I've got 100 divided by the sine of 76 times the sine of 65. And when I'm done here, I see that Tom is 93.4 feet away from this balloon. Okay. So we can do word problems with these. The very first thing we got to do is draw a picture. And then from there, it's not too bad. Okay, so wrapping things up, this is the law of sines. I'm going to post an assignment here in a minute to go along with this video. Good luck on the assignment. Let me know if you have any questions. Okay, bye.